Thank you for joining us, Aparna. Very happy to have you here today.
Happy to be here.
So, welcome everyone. Aparna is joining us today. Aparna started at IBM as an engineer, actually, and grew all the way up to VP of IBM's Quantum ecosystem. She helped write the commercial strategy for IBM as an MBA from MIT. And you are now Chief Strategy and Sustainability Officer of Schneider Electric's, 32 billion energy management business, and also a board member at QuantWare. So give her a big hand. So Aparna, I'd like to start a little bit with your history. Can you tell us a little bit about how it was building up IBM's Quantum team?
The best part about Quantum is every day is new, and I think that is true here, and that was very true when we started working on IBM Quantum. So just a little bit of how I don't have a physics degree, and I was one of the only few people without physics degree in IBM Quantum, and my conversation with Quantum started pretty non-traditionally. I actually started looking at Quantum as a strategist. I was in IBM corporate strategy, and our CEO at that time asked the question, hey, we have this small project in research. Should we shut it down? When can I make money out of it? That's taking a lot of money. What should we do? So we went in and sort of with the research team started looking at, should we actually shut this down? And came back with, oh my God, no, this is the best moonshot in the world. The impact is going to be tremendous. Doesn't matter what you do. It's the potential, the sheer impact of Quantum is so huge that a company which is a technology-based company should definitely be working on it. And that was the start of my Quantum journey, understanding, learning from a very strong technical team, and then going and crafting almost a 10-year roadmap of what IBM Quantum should look like. The story which I was telling Matthias yesterday is we wanted to explain to the board how we talk about milestones, and we sat in a room, and actually wrote down the definition of quantum volume and went and spoke to people who were not quantum experts about how you actually think about progression, milestone, and that's how we started. A couple of years down the lane, I got asked to go actually execute on some of the strategy we'd written. So work with the technical research team and actually develop an ecosystem. An ecosystem to me is important because in Quantum, you cannot do anything in isolation. You actually need to think about various pieces. You are not an expert about everything, so you need to bring a community together, and you really need to think about democratization. So I'm assuming a lot of you have heard about IBM Quantum Network. That was my baby. We grew it, reached about 255 partners before I decided to take a new adventure.
And we'll touch on that new adventure later, but I'm very curious. I mean, that strategy that you wrote with that team has been incredibly successful. I think IBM announced that they did $1 billion in revenue last year in their Quantum division. Yeah. Did you envision that beforehand? I can imagine a big corporate like that is fairly financial driven in making these decisions, but it's also at that time, this was so forward looking and so, I guess, not clear when this level of revenue would come. So how was that?
We did have crazy roadmaps, yes. We did have ambitious roadmap. And I will also tell you this, I think a part of it comes from having an amazing research organization which sort of always kept pushing the boundary of what was possible. So we went in with approximate numbers for 10 years. That's the only way you can get board to actually approve. Unlike startup where you go to investors, the board is basically your investor community. You kind of go in and say, I need this much money every year. And oh, by the way, you're not going to see any revenue for 5 years. You can imagine in a well-established company, a $70 billion kind of saying, hey, no revenue for 5 years, but please keep giving us so much money so that we can go execute on it. It was not an easy discussion. So yes, we had envisioned. Was it exactly according to the plan? That's questionable.
I guess it never is.
It never is.
And can you tell a little bit about the people that you worked with there in a general sense? Because also, of course, we have some brilliant technologists here. I think in order to draft a strategy like that, that's future looking, you need to work with people that are, let's say, quite visionary. How was that environment for you? I mean, obviously some of the names that you worked with at the time are now very famous in our space, Jake and Betta, for instance. Can you tell a little bit about that? What was the culture and the feeling like?
I will give a lot of credit. Actually, the reason I really, really enjoyed working, and I worked in IBM, by the way, for 17 years, right? So I worked in IBM for a really long time. I had many different missions, within IBM, and Quantum was one of them. It was the one which I exited with, but it was not my only mission. But what was amazing about Quantum, yes, I worked with, Jay was my boss. Jay Gambetta leads the entire Quantum, IBM Quantum for IBM. I think what is super interesting is we would come up with these roadmaps for quantum, and you're building a full stack quantum computer, which we didn't know if we can actually execute on. It was ambitious, it's crazy, and the team was extremely proud about the fact that you hit every milestone the way we had announced. But there was a lot of sweat equity which goes behind that. There's a lot of actual science, hardcore science, which goes behind that, and I find that amazingly exciting in a lot of ways. I'm not answering your question because there is no good way to answer. It's the energy of the people which makes a team special at the end of the day. And whether it's IBM or it's somewhere else, it's about the technologists believing that they're working on something which is groundbreaking. It's kind of having that ambition, not necessarily to do the next thing, is to really have a breakthrough every time you're working on something. And I think that is what makes this whole entire community around quantum really pretty spectacular.
I think that's very recognizable for a lot of people here at QuantWare. So maybe switching gears a little bit, so you're clearly still very passionate about the space, and then at some point you decided to move to Schneider Electric, which doesn't have a quantum division yet. Can you explain a little bit how that decision process went for you? Why make that move?
This is a hard one for me. By the way, I surprised everybody. Including myself, when I made that decision. When Schneider and I started speaking, they'd approached me. I had zero ambition to leave IBM. I was having a lot of fun. We were doing something really cool. The only reason I picked up Schneider's call was because they'd just been named by Time magazine as the most sustainable company in the world. And I was like, wait, what does that actually mean? Let me go actually have a conversation with them and understand, is this all marketing? Is there actually things? And we were starting to actually, in IBM Quantum, we were starting to speak about using quantum for sustainability use cases with various clients. So it was on top of my mind on what does it mean. And then here comes Schneider, and I was reading, coincidentally, Time magazine that week, and I was like, oh, let me find out what this is about. Second thing which I loved was I realized sustainability for Schneider, at least, was not on the paper. For example, a big part of my compensation today is based on, do we actually meet our sustainability targets, right? Very rare, very hard, where a company is basically incentivizing their leadership to actually think about, how are you affecting the carbon footprint? Are you actually reducing your products? How are you developing it? And third thing, it was a gut and feel. You actually like the people. You're saying, hey, I can actually learn from this crowd, very different, but it's this next genre. So when they came back and they offered me things which we were talking about, I was like, you know what, I'm going to make a jump. I have no idea if this is a good or bad jump, but we'll do it. And it was really, really, really hard for me. It was not an obvious decision. I was leaving something I actually was enjoying and going towards something which I had no idea if I would enjoy. That was a very long answer to your very short question.
But I mean, it does shed a lot of light in how you're motivated. And also there, I think the timing is spectacular with all these hundreds of billions of dollars in CapEx being invested now in the AI boom and all the impact that's having on the grid and also the energy usage of that going up as a percentage of the total energy usage, especially in the US. How do you think quantum ties into that? Because you quite often see quantum compute being presented as this will offset classical compute, which we think is incorrect, right? It's a new type of compute. But how does energy usage tie into that then? Because obviously if you can do classical compute more efficient, then that leads to energy savings, but it's not that obvious. It's a new class of compute. So will the impact of quantum computers on this energy usage of compute be net positive? And how will quantum compute fit into this new massive infrastructure build out in compute by these hyperscalers?
It's a very interesting question. I'll start with some facts. So in 2024, about 93, this is US alone, 93 data centers are coming online. About 84 are under permitting. The ones which are getting built are 6 times larger than what was built a year ago. That's the scale which we're talking about in some ways, right? We used to talk about, oh my God, your 50K data center is so huge. That's peanuts right now. And a lot of the conversation which we have, because we are the world's largest provider for data center infrastructure in Schneider Electric, cooling, uninterrupted power supply, switch gears, etc. Schneider actually supplies all of that. Is that earlier we used to be just suppliers. We would just do, hey, you want cooling? Here's cooling. Here's UPS. Here's the thing. Right now, we are actually working with the chip providers, re-architecting the new data centers because you can't think about them in isolation, right? And those builds for next 3 years, we think we have a reasonably good idea of what are the AI related builds which are going to come and which are all greenfield. Now put quantum and then put different heterogeneous modalities into it. Now there are a lot of open questions in architecture. One is simple. Is quantum and AI will it be in the same data center? And when we talk about AI, I want to be very clear. Accelerated compute, classical non-accelerated compute, quantum, will it be in the same data center? Will it be in a different data center because you don't need latency? How do you architect this? Where do you actually place them? What are the requirements around it? These are actually pretty hard questions which we are not really thinking about because we are building in our own silos right now, right? To me, it's not about if quantum, it's about when quantum happens. Are we being reactive to it, or have we actually thought about all of these things which are extremely important? Because at the end, what are we trying to do? The end user doesn't care. I'm sorry to say this, and I don't know if this resonates, doesn't care if you're working on quantum or AI. Really doesn't care. What they care about is what is the value unlock you're creating? What is the use case which you're solving for me? And the reality is they are going to use AI. They are going to maybe use trapped ions. They are going to use superconducting based on the use case which they are going to deliver. How we put all of this, do we do it in a way which is the best, most energy efficient? Do we understand how we actually structure it? Are actually pretty important question. If there's anything, I feel like I'm giving you long answers, sorry. If there's anything Gen AI has taught us, is that you will have these moments of breakthrough and you will not be ready for those breakthroughs and you will be reactive. The whole Gen AI is not new, it's been there for years. But what Gen AI really taught us was the adoption curve went really high as soon as you could democratize it. And then suddenly you have all of these things which are happening, and you're being super reactive on, hey, am I modeling it right? Am I thinking about it right? Am I using the energy envelope right? And for us as a quantum community, I think these are questions as we are building it and as we are designing it and as we are creating new technology, we should be doing it right now, sort of learning about it. Did I answer your question?
I think so, but I'll ask a few follow-up questions to delve into that a little bit deeper. So I think, you know, part of what you're seeing in AI now is that there's this massive capital investment wave, but it's still, I think, not reaching its full potential in terms of adoption. Like that seems to be where the bottleneck is to get to the full economic impact. Whereas for quantum, I think it's more about scaling up these systems to very large sizes that they get to this new area of compute. And you know, it seems to me that some of that might actually even, you know, more or less intersect to some kind of new point where all of that compute becomes mainstream all of a sudden. What do you think for the quantum side? You mentioned the end user won't care, they want to use the best compute. What then is the figure of metric? Like, is that, you know, highest fidelity gates, or what are we, or is it at a higher abstraction level, more around, you know, maybe the ease of use or the cost of use?
I'm going to give you a corporate answer. I apologize for it in advance, right? I think it's going to end up being more something akin to cost of use. We have to think about it. We used to always think about PUE in data centers. We think about today, a lot of AI conversation is tokens, right? Tokens for energy, tokens per water usage, tokens for others. That's the way they're trying to figure out how expensive is AI. We haven't come to that point as yet. But the way you want to think about quantum eventually is going to also probably have to be in a tangible way, which makes sense, not just to physicists or not just to scientists, but also to a person at the end, where the cost per watt actually also drives responsibility in some way. I don't know, is it cost per watt, is it cost token per watt, etc., but we'll have to think about that metric.
So basically what you're saying is more, let's say, the economic side of things. Can we generate a return? Is it, let's say, compute per dollar, compute per watt?
It's like this, right? So think about it. My 10-year-old asks Alexa for everything. He's not thinking about how expensive it is. He's not actually thinking about it. He's just saying, oh, it's easy, it's free, I don't care. Now, as a user, how do you make a user more responsible, and how do you make sure they're not using when you have a nail, you want to use hammer. You don't actually end up using a different tool to hit the nail. You want to use the right tools for the right thing. And it's not just the builder's responsibility to provide that, it's the user's responsibility. And I think the economic model makes corporates more responsible, makes the end user more responsible, because the impact is easier to evaluate in some ways. And by the way, I've had this conversation with my 10-year-old about data centers and energy. He doesn't care. So
a good metric of that, good proof. So you recently joined our board, and I think you have some idea of the problems we solve by now. What do you think are the main problems that the industry should tackle, and how do we fit into that? Scaling up towards these, 10,000 and 1 million qubit systems that fit into these large data centers.
So as I started talking with QuantWare, one of the things which I really do like is you want to think about core problems. And the core problems are about 15 years ago, or even 16, it was like, hey, can we actually get more than 2 qubits in a chipset? That's no longer the thing which we're talking about. Even if you get a lot of qubits, you still have to think about how do you package them, how do you actually scale them to a point where even if it's utility scale or NISC, you have enough of qubits to do something reasonable with them. And that does mean that packaging is going to be an issue, how you think about the things. And I like how we are thinking about VIO, how you are thinking about VIO, because I do think that's a bottleneck, right? When you think about the bottlenecks over there. And for us to actually really get to that point where quantum truly becomes useful, I think you have to think about these things well ahead of time and really think about scale. And I do think the VIO, so that was one thing which I really liked. The second thing which I like is it feels tangible. It feels like it's pretty, and maybe it's between you and Ale. You've made it simple enough to understand that it feels like, okay, I understand the problem statement. I understand what you guys are doing. I think that actually should work. And it's a great place to go and see if you can help scale it.
And so, well, thank you, first of all. If you then, look at VIO, how do you think we can best position that to make the most impact in this space?
This is a hard one, because if you had asked me 3 years ago, I would have said, guys, full stack is the way to go. You want to own the entire thing. Like, look, I was spending and living and breathing in a company and in a team which believed in that. But I was also building ecosystem, right? And one thing which I do realize is the problems you're solving. You don't know what you don't know. That's an important aspect of what we are doing here. And it does help when a community comes together and you're solving different types of problem in different ways, because you need to look at a problem and approach it differently. And when you're tackling different stacks in the technology separately but towards a common goal, I think you can accelerate much faster. And that, I like that idea. I actually like the fact that it's not full stack, because that actually means you can bring the best into play. You can actually be a little bit more pragmatic and say, how do I actually accelerate the science behind this? And how do I accelerate the technology behind it much faster? But when you try to own the entire stack, sometimes you forget that you're actually doing it for the industry. You're trying to establish a much more bigger play over here. So I think you'll get to a much bigger value unlock when you do these things around it.
Maybe zooming out a little bit, because you mentioned this full stack. What about the software space? There are, there are a multitude of players there, going from the application layer all the way to the low-level pulse calibration layer. It is not always, I think, as crystallized how those levels are divided. Do you have a clear picture on that? Because obviously, IBM's ecosystem has a lot of very interesting software partners in there. What are some of the most interesting areas for you in that space?
There's a debate which I think is worth having. Is hardware and software always going to be interconnected? For how long, right? Because if you look at the classical end of it, a lot of the hardware has been abstracted away. You still need the hardware, but it's abstracted away. So the two software and hardware can work pretty independent of each other, because there is software development which happens, but then you upgrade and you're able to do that. I think quantum is a little bit further out. Now, is it 10 years? Is it 15? Is it 20? I think that is debatable based on what your beliefs are. But to me, that's a little bit further away. You still can't abstract it away completely. So there is these pieces around control. There's pieces around mitigation, which I think are important elements of it, which you need to say, how do you tune your hardware much better so that your performance you can get the best performance, because you're still kind of stabilizing a lot of that. By the way, if you go back to World War time, classical compute was exactly that. You needed to spend a lot of time actually figuring out how to condition and how to do it from the hardware and software were pretty interlinked. I do think there is value in at least looking at application. There is an open debate, and I'm not sure I'm right about this, I'll be honest. is simulator the best way to do it, or do you actually, is there value to it? And you've seen a lot of companies which are pure software, quantum software companies, which are doing it and saying, hey, the hardware will come later, I'll optimize my software on it. I'm not sure that is valuable. I think you have to be more at the level where you can still play around with the hardware, that the algorithmic level, the error mitigation, the control, which I think brings a lot more value at the stage of maturity you are. But on the other hand, the application layer lets you think about how will a user interact who's used to interacting with classical compute in a different way.
I think a few parts of your answer that I think are really interesting. I think this analogy with the way classical compute evolved, I think is very interesting. That's not just on a technical level, that at first everyone was literally moving around bits and then assembly and getting to higher and higher abstraction layers, but also on a business model level, that at first everyone was vertically integrated and then specialization happens. Intel came around, no one made their own chips anymore. TSMC came around, and now Intel is a little bit in trouble because of specialization continuing. And I think the second bit that I found really interesting is, especially, let's say, one level lower, below the application level, on, say, the things like magic state distillation and quantum error correction. I think what you can see over time is that as the theory people and the software people do their work, the hardware resource requirements are going down for certain lower level concepts, whereas the hardware is quickly scaling. And so at some point, those curves should intersect. And it makes me quite optimistic for the timelines of all of this.
Can I add one thing? I do think it's important for us to agree, you don't solve the problems of today. If you're solving problems for today, you're already done. You're too late. You actually want to solve the problems for tomorrow. That requires, and this is true even in right now, my role is to lead strategy for a $32 billion business, which is pretty well established, right? We know our growth curves. We know exactly where we are going, exactly where we are going for 2 years. We are making strategic moves with 2 years in mind. But a bulk of my time is actually looking at what are the problems which are coming 5 years from now, 6 years from now. How do I actually disrupt my own business, which is really hard for a established business to do, right? Because when I disrupt my business, I'm putting billions of dollars at risk. But I think that's the beauty of being startup, is you should be constantly thinking about, how do I disrupt what I'm doing? How do I think about it differently?
Maybe apart from the technical challenges that we need to solve, what are some of the, let's say, non-technical challenges that the industry needs to solve?
Okay, a couple of them, and they are not going to be popular answers. I know that because I've tried it in my thing. One, I do think there is this, people who understand quantum don't always understand classical. People who understand classical don't always understand quantum. So how do you, and this is not a blanket statement, by the way, but I would say a large majority is that, right? When you speak two different languages, you still need to learn to translate these languages together. That means that you have to start thinking about what does that translation point look like, etc., right from the beginning. Think about it. You come to me, you say, hey, I have the best technology in the world. Here's the thing. From a corporate perspective, as a responsible head of strategy, I would say, tell me, what does it mean for my bottom line? How does it save me? What is the revenue impact, etc.? And you have to be able to translate at some point all of those. So that's an example of that. The second thing really to think about is, that's one, right? The second thing to think about is really understand not just what is changing in quantum, but what is changing around you, because there's implications, right? When we started first looking at quantum, when I was looking at it from a strategist point of view, we were like, the machine learning is going to be the use case around this. AI is never going to be able to catch up. AI has also, like the classical, is also advancing at the same, very fast, at the same time as we are advancing on quantum. So the way you look at the use cases may also shift. Understanding what is your target, and that target is moving, is also important aspect of it.
Yeah, I think that last bit is quite essential. That if the approximations that AI algorithms can achieve are good enough for most economic use cases, then then we need to look somewhere else for those first economic use cases. And it's a very interesting time. I mean, your reference to it yesterday and a little bit earlier in this interview, these almost two intersecting revolutions happening at the same time. And to your point about the classical people and the quantum people coming together, I think that's something we notice as well, that as we've gotten bigger and the challenges shift more towards engineering, we have more and more non-quantum people in our team. Mm-hmm. And I think that there's a lot of, let's say, cross discipline learning both ways. A lot of semicon people in our team now, and it's teaching the quantum side of our organization how things happen in the classical space and vice versa. Maybe shifting a little bit to another, I think, dynamic in our industry is the current, let's say, state of geopolitics. There's obviously some kind of race between the US, Europe, China, I think. What are some of the parameters we should be thinking about as we navigate that?
You know what, I'm living, breathing this right now in my day job, which is how do you think about the geopolitics implications, even from a short-term perspective. And a few things to think about as we are building the business is, one, who are you serving and where are you serving becomes actually an important aspect of it, because more and more, this will not be a surprise, we are thinking about how do we create what is important for Europe, how do we create what is important for US, how do we make sure that we keep our crown jewels there, how do we make sure that we have the right IP, we have the manufacturing capabilities, etc., in specific geolocations, and I think that becomes a parameter. But then the second aspect, which I think is important in this world of sovereignty, I think I pronounced it right, you also have to think about talent, because talent is not like location specific. You just have to figure out how do you get the best talent to do the things which you need to do to move the needle, and that may be different answers. Like Europe may have a certain amount of talent in a specific place, you may have some in US, you may have some in China, and you'll have to think a little bit more broadly about what is that talent and how do you cross-pollinate.
Definitely recognize the working in such an international environment makes life interesting. I think we have, what is it now, 16 nationalities in our company, and it makes for very interesting dynamics and a lot of fun, and sometimes a little bit of misunderstanding.
But you know what, it's this, the technology doesn't know sovereignty. Sovereignty is about how we are defining it. We have to appreciate and we have to develop with those borders in mind. But at the same time, as you're developing technology, you have to think more broadly about the people, talent, and what are the skills you kind of need as well.
And I think one other element to that, I mean, obviously this is something we already deal with a lot, these, let's say, geopolitical dynamics, because the technology that we work on, is so important and it's going to be so powerful. So, and of course, if you're working on something powerful, then that can be used for good things, but also for for not good things. So how do we ensure that what we make will be used for the good of the world, or how do we maximize the chances of that? And also, where is our responsibility there as a company and as an industry?
Oh, this is a hard one. So, sorry, I have to think, give me a minute to think about it, because there's so many different ways to do it, right? It's like quantum for quantum for good, quantum good for quantum. And I think about it in terms of energy. Let's take an example. You will require a reasonable amount of energy to actually, however you take it, to actually make a quantum computer work. Now, as you're designing it, how do you make sure that you can optimize it and think about it on what does it take to run it in a more sustainable fashion? Are there small design tweaks? What we are doing with VIO hopefully will lead to like better heat distribution, better energy footprint, etc. I think that's an interesting way to think about it. But on the other hand, you can also use quantum to actually do more use cases where you can actually create more sustainability, like quantum for sustainability. How do you optimize certain things? How do you do those things? So there are always two sides to the good and bad. That's one piece of the equation, is how do you make sure that whatever you're building with the future in mind, and you're building it in a way where you're optimizing things and you're being thoughtful about it, and not this is the easiest way to do at a cost of something, let's just go about it. Rather, you're thinking about, does this actually solve some problems? What are the other problems it brings about, etc. And on the other side, when you're starting to use quantum as a tool, because at the end of the day, that is what it is, right? It's a tool. Can you actually use it in the way it's supposed to be used, and what are the parameters you put around it? I didn't quite answer your question, but I think it's a super hard one, because the ethics, the roles, the responsibilities is so broad. We haven't ever been able, it depends on what cut you take.
100% agree. And I think to some extent it's almost, it's part of the reason it's so hard is that it's not solvable by some algorithmic answer. Like, these are the rules you need to stick by. It's almost a cultural problem that you ingrain this, that that 10, 15 years from now, that the organization that we build together is still holds those same values and is not, selling to bad actors or something. I think that's part of what makes it so difficult to articulate as well.
And I think it's also important, and that will be a part of your job as well, right? What is the vision you have for the company beyond the product itself? What does this company contribute towards the impact around you? I think that becomes an extremely important point as you scale, to be public about it. And for you guys, I'm going to go back to my 10-year-old, right? When he used to be in daycare, the first month of daycare, you actually put, here are our cultural norms, here is how we'll behave with kindness, we'll behave with this, we'll be respectful, we won't talk over others, etc. I actually do it with my teams. When I go and start running a new team, I'm like, okay, let's define what are the microculture things, what are the things which we will do, what are our team norms which we will agree to. And that's it's almost a commitment to each other on how we operate. I just like that. So the question for you guys back is, what is the commitment you're making as an organization to do the question which you asked me? How do you make sure that what you're doing it in a way where you feel good? At the end, ethics, ethical, etc. is about you feeling that you're doing the right things for the right reasons. And then what is your team norms and what are you agreeing to will be an important aspect of it.
I think that's wise and wonderful advice. Thank you so much. Give a big hand for it.
Thank you.